Let's take a look at this question together. It says if we have the lens below and it's made out of glass, it will be what type of lens? Well, the lens, if you notice one thing on this lens, we're going to assume that we're going from an index of refraction of air to an index of refraction of glass, which is a higher value. I remember 1.5, but it's not always that. What I do know is from the picture, assuming that the picture is somewhat correct, that this radius of curvature, this R1, and the radius of curvature of R2, let me draw this correctly, R2, R1 is a larger value than R2. This has a very shallow curve to it. It's a really big circle, whereas this one is a very small little circle. So the center of this circle is small. The center of this circle is very large, assuming that we have an optical axis along it. If we know that R2 is smaller than R1, then we can say that R1, 1 over R1 is actually going to be smaller than 1 over R2. A large number is bigger than a small number. 1 over a large number is smaller than 1 over a small number. So when I look at the lens maker formula, my focal length is going to be n minus 1, assuming I go from index of refraction of glass to air, 1 over R1 minus 1 over R2. This value right here is positive, and we'll know if it's converging or diverging based off of if this is positive or negative. Well, since R1, our first surface, is actually a negative value, so this is a minus value. I should probably put absolute values on these things. R1 is a negative value. We are on the negative side of the lens. So this is a minus value here, and we're going to be subtracting off another minus value. It's kind of a weird way of looking at it. So we have a minus value subtracting another minus value. So these two, I guess what I'm trying to say is that this number is negative. This number here is negative, but we're going to subtract a negative number. And since R2, 1 over R2 is larger than 1 over R1, this whole piece over here is actually going to be a positive value. Minus 1 over R2 is going to dominate this term over the minus 1 over R1, or the negative radius of curvature, 1 over the radius of curvature. So what that means is that this focal length has a positive value. 1 over the focal length is positive, the focal length is going to be positive. Long story short, the focal length is greater than 0. And what does this mean? Well, focal length greater than 0 means that we're going to have a converging lens. If we were to flip this lens around and look at actually choice D, then we'll see that R1 and R2 switch their roles, but they also gain the opposite signs. So R2 is positive, we subtract off a 1 over R1, which is now negative. We've switched the roles, but R1 over this surface is still dominating 1 over this surface.